Hello everyone, my name is Shalanda Chaudhary. I have created a deep dive video course on Azure Application Gateway. In this series, we'll start from the basic fundamentals and then dive into advanced topics so that you gain a solid understanding of how to configure, optimize, and troubleshoot Application Gateway in various scenarios. Slide on your screen shows the different topics which are covered in this course. Each video is carefully crafted to be a hands-on experience. We'll not only discuss the theoretical concepts, but also walk through the practical demonstrations, providing you with a real-world perspective on how to use Application Gateway effectively. And if you want to follow a specific topic in this course, you can go to the description of this video and click on the time provided in the front of the topic. That will take you straight to that part. So let's start. In this video, I'll be explaining about what is Application Gateway, its features, components, and how it works. So let's start. So Application Gateway is a web-based load balancer that works on OSI layer 7, which is an application layer. So if you look at the OSI model, there are 7 layers, and Application Gateway works on layer 7, which is an application layer. And it is also called as HTTP layer. However, if we'll talk about the traditional load balancers, they mostly work on layer 3 and layer 4, which are network layer and transport layer. So this means all the routing happens only on the basis of source port, destination port, and source IP address and destination IP address. However, Application Gateway is an intelligent load balancer because it works at application layer. So it routes the traffic based on incoming request HTTP attributes like host path based routing or URI based routing or the host headers. If we'll check the diagram on the right side, this shows how host path based routing works in Application Gateway. For the traffic hitting the Application Gateway checks the URI path. If it finds images in the URI path, it will route the traffic towards image server pool, which is the backend specifically designed to cater images. And if it finds video in the URI path, then the traffic will be routed towards the video server pool. So in short, you can say Application Gateway is a specialized load balancer designed for web applications, and it offers advanced routing and security features at application layer. Let's move on to the features of Application Gateway. So the first one is SSL TLS termination. So SSL TLS termination, it allows the Application Gateway to decrypt the HTTPS traffic before it passes to the backend server. So it offloads the CPU intensive decryption from backend servers, which improve their performance. There is one more benefit of using the SSL TLS termination, that is the centralized certificate management. So you don't need to manage the certificates on the backend server. However, you can just manage the certificates on the Application Gateway, and all the decryption and the encryption will happen at Application Gateway only. But this doesn't mean that Application Gateway supports only SSL and TLS termination. So it supports end-to-end TLS encryption and decryption. Another one is the auto scaling. As the name suggests, Application Gateway will automatically adjust the number of the gateway instances based on the traffic demand. So if in case there is a performance requirement during the traffic spikes, it will increase the number of instances, and during the period of low traffic, it will reduce the number of instances, which will further reduce the cost of using Application Gateway. Third one is zone redundancy. Application Gateway is a regional service. So that means for the case of high availability and fault tolerance, you need to deploy Application Gateway in multiple regions. However, after the support for Azure availability zones, now the high availability and the fault tolerance can be provided by distributing the Application Gateway instances across different zones. Now Application Gateway provides the feature of static virtual IP. So that means the public IP which is created for the Application Gateway will remain unchanged till the life cycle of Application Gateway. This is a very useful feature because the DNS registration of the custom domains to the public IP of the Application Gateway need not to be done multiple times. Another one is Web Application Firewall. So Application Gateway during the creation provides a feature where you can enable the Web Access Firewall or Web Application Firewall. Using the Web Application Firewall, Application Gateway protects your web applications from different security threats like SQL injection, cross-site scripting. I'll create a separate video for Web Access Firewall or Web Application Firewall. Another one is Ingress Controller for AKS. This is very useful feature when you're using the Azure Kubernetes cluster. Previously, this support was not provided, so you had to use NGNX Ingress Controller or any third-party controllers. But now Application Gateway can be used for traffic routing or load balancing of containerized application. Each one is URL based routing. So the application gateway checks the URL of the traffic and then using the different routing rules which are created for the different backend server. Like if there is a music in the URL, it will go to the backend servers which will cater for the music, and if there is a video in the URL, the traffic will be routed to the backend server which can handle the video traffic. Another important feature is multi-site hosting. So now you can use the application gateway to host multiple domains. You have to create separate routing rules, separate backend servers, and application gateway will be smart enough to check the traffic and redirect it based on URL or HTTP headers. Application gateway also provides redirection. In some cases, the URL of an web application has changed, but the users are still reaching to the previous URL. So in that case, there you can set up a redirection on the application gateways. If someone is using the old URL, still it will be redirected to the new URL and the traffic will be handled by the backend servers. There are other redirection like HTTP to HTTPS redirection. So if a user is not typing HTTPS before the application, still all the redirection will be taken care by application gateway. Another important feature is session affinity. It is also called as sticky session. This is used mostly in the case of the application which use cookie-based sessions. So that means a user session state should be maintained and the traffic should go to the same backend server which was catering the user or the traffic. Application gateway always load balance the traffic between the backend servers. To maintain the session state, session affinity has to be enabled on application gateway. And the last one is rewrite HTTP headers and URL. Using the application gateway, now you can modify or rewrite the HTTP headers or the URL from the request or the response. There are two versions of application gateway in Azure which can be deployed, version 1 and version 2. So the version 2 supports more features as compared to the version 1. And now Microsoft recommends to deploy version 2 instead of version 1. And if someone is using version 1 in their existing environment, it's recommended to migrate to version 2. So on this slide, there are the features which are supported by version 2 and not available in version 1. Version 2 supports auto scaling so that it can auto scale based on the traffic loads. Version 2 also supports zone redundancy, static virtual IP, AKS ingress controller. We have discussed this in the previous slide. Version 2 now supports the key vault integration, which means the certificate used for TLS authentication of application gateway can now be stored in key vault. So the rotation and the maintenance of the certificates can now be done in a more efficient way. Version 2 also supports header rewrite, enhanced network control, which we have already discussed. Now mutual authentication is supported by version 2. Mutual authentication is also called as client authentication, where the web browser used by the server has to present the digital certificate to application gateway, and then application gateway verifies that certificate against its own certificate. Once the user certificate is accepted and trusted by application gateway, then the connection is established between user and application gateway. It's like an added layer of security. Version 2 also supports private endpoint support and health probes. Application gateway constantly monitors the health of the backend servers, and the routing of the traffic happens only to the healthy backend servers. It prevents the packet loss now. Now I'll talk about the components and the workflow of the application gateway. Here are some of the components like front-end IP address, listeners, routing rules, HTTP settings, backend pool, and health probes. I'll show these components in Azure portal so that it will be easy to understand. This is not a hands-on video, so I have already deployed the application gateway. I'll create a separate video for step-by-step demonstration of application gateway deployment. So before the creation of application gateway, I created a virtual machine. It's a Windows 2019 server and I have installed IIS on it so that it can act as a web server. Now let's go to the application gateway. Based on the Microsoft recommended naming convention, I have named it AGW, which is Application Gateway Demo, and AAE is the short form or abbreviation for Australia East, and 001. So it's in the resource group RG Demo Application Gateway, and it's connected to virtual network VNet Demo AAE, and the subnet is app gateway subnet. The condition for creating an application gateway is the subnet should be empty. So if you look at the configuration, you can enable the auto scaling from here. Right now it's manual. There is only one instance of application gateway which is available, and HTTP2 is enabled. So if you want to auto scale it, you can set up the minimum instance count and the maximum is 125. Let's discard it now. Web application firewall WAF can be enabled, but right now it's only the standard version v2. If you want to enable the WAF, create a new WAF policy and then save it. Backend pools. The Windows server or the Windows web server which I have created is added to the backend pool. Now there are multiple target types which can be added based on the IP address or fully qualified domain name. So that means application gateway is not limited only for Azure. It can be used for on-prem as well as the different clouds. There should be a connectivity between the virtual network where application gateway is deployed and to the target virtual machine. And you can just directly define the virtual machine scale set and the app services in Azure. So for now, and the target is demo web 013, which is a private IP assigned to the server. In the backend settings, it is defined that the backend protocol is HTTP. You can enable HTTPS, but for that we need TLS authentication. The backend port is 80. You can enable the cookie-based affinity, which is also called as session affinity from here, and the connection draining in case you are making the changes on the website and you want the users to get the latest changes, then you can do the connection draining from here. Front-end IP address. Application gateway can be used as an internal web load balancer as well as external. So a public IP is created if you want to use it for the external load balancer. Here you can see one public IP is created for it. So that means if someone wants to reach the application gateway from internet, this public IP will be used for it. And in case of the different URLs like the custom domains, the custom domain has to be registered with this public IP address. You can enable the private endpoints from here or the private links. SSL profiles can be created, which means TLS authentication, where the certificates has to be provided. As you can click here, you can see upload a new certificate. Listeners. A listener is created for the front-end IP address, which is a public IP to the port 80, and a routing rule is associated with it. In the listener type, you can define the basic, which is by default, or a multi-site where you want to use the different domains for the application gateway. So the routing rules are defined here, where the listener is selected, which means if traffic hits the public IP of the application gateway, then it should go to the backend target, which is the backend pool that is defined here. You can set up the redirection also. It can be temporary, permanent redirection to a different target listener. You can create the rewrites from here and the health probe. You can define the health probe on which port application gateway should monitor the backend pools. And if there is a specific path it should look for. So these are the components of application gateway. Now let's discuss the workflow. So when a user using the web browser hits the IP address of application gateway, it can be the custom domain if you have registered it to DNS, otherwise it should be the front-end IP or the public IP of the application gateway. Once the traffic goes to the application gateway, it goes to the listener. Listener is created for the public IP and it has the routing rule attached to it. So then the traffic goes to the routing rule and the routing rule defines which backend pool or which backend server the traffic should go to. So it can be multiple virtual machine scale sets, on-prem or the different app servers or Azure App Services. If we'll just look at the application gateway which I have deployed, there is a public IP attached to it. So let's copy this public IP. So we have listener, routing rules and the backend pool, everything in place. So if we'll try to hit this public IP from the browser, it should show the default page for Windows Server. So as you can see, this is IIS services are enabled on the Windows Server and this is the default page which comes up. And it's working fine. As we have already discussed, there are multiple features which we can enable like multi-site hosting, path-based routing, URL-based routing, we can set it up. So to conclude this video, Application Gateway is a smart web-based load balancer which checks the HTTP header and the URL of the request and then does the routing accordingly. Application Gateway provides a lot of features which makes it a good choice for the load balancing and routing of web applications. That's all for this video. And in this video, I'll show the step-by-step deployment of Application Gateway and the setup of URL-based routing. In the previous video, I have explained the components, features, and workflow of Application Gateway. You can find the link in the description of this video. So let's start. I have already created few resources to save the time on the implementation of Application Gateway. So there is one resource group, RG Demo Application Gateway. As you can see, there is a virtual network already created. In this virtual network, there are multiple subnets where the subnet 01 will be used by the backend servers. App Gateway subnet. This subnet is created only for Application Gateway because Application Gateway requires an empty subnet. And the third one is the subnet used by Azure Best in Service. Azure Best in Service is a Jumpbox service which is managed by Azure. And I'm using the Azure Best in to log into the servers. Otherwise, I have to assign a public IP to the backend servers and to log into them. So there are three backend servers which I have created. Web AWS 01, Web Azure 01, Web Azure 02. And I've created these servers to show the path-based routing and the default routing which I'll set it up during the deployment of Application Gateway. These servers are Windows 2019 servers, and in this video I'll install the IIS servers so that these servers can become web servers and act as a backend for Application Gateway. Apart from this, I have added one custom domain to Azure. I have bought one domain devsecopstech.online from GoDaddy and I've added as a DNS zone here. And in this video, I'll show how we can create an alias for the custom domain to the front-end IP of Application Gateway. So let's start by installing the IIS feature on one of the virtual machine and convert it into web server. So let's go to Web Azure 02. I'll connect to this server using the Bastion service. Go to Bastion. Let's connect. I'm into the server now. Let's open Server Manager. And add roles and features. Next, role-based installation. Next, and web server, which is IIS. Add this feature. Next, next. We'll use the default settings only in this case. And install. It should be installed within a minute or so. As you can see, IIS is installed now. Let's close this and open the IIS manager. And in the IIS manager, you can see the default website. Before we make some changes to the default websites, let's check this in browser if it's working properly. Localhost. As you can see, the default web page is available now. So let's go back to the default website. Click on the default document. And there are default settings like default.html and index.html, HTML, which will open with this default website. I have already saved few files in the C drive location files. This is a default page for Web Azure 02. So let's copy this HTML file to the default location. Let's go to C drive, inetpub, www.root, and copy it here. And then go to the default website, default document, and add mypage.html. Okay. So now in the web browser, when I'll open the localhost, it should show the new default page. So now one of the web server is ready. To save time, I have already set up the default page for web server Web Azure 01 as well as Web AWS 01. So let's start with the deployment of Application Gateway. Let's go to Application Gateway. create. Select the resource group RG Demo Application Gateway. Let's give the name AGW, which is the abbreviation for Application Gateway Demo AAE 001. AAE is the abbreviation for Australia East. The region is Australia East, version 2. We are not installing WAF here. Let's not enable the auto scaling now and start with only one instance. We don't need an availability zone for this. HTTP2, by default it will be enabled. Let's select the virtual network and app gateway subnet. Because it's an empty subnet, it's automatically picked up by application gateway. Let's create the front ends. Yes, we need a public IP because the same public IP will be then registered to the custom domain. Let's create a public IP. Pub IP app gateway 01. Let's add the backend pool. In this backend pool, I'll add the two web Azure servers so that I can show how the load balancing works between the two servers. And the third server, which is web AWS server, that will be used for showing the path-based routing. So let's add the target virtual machine, web Azure 01. It is the network interface card for the server. Let's add another virtual machine also, web Azure 02. Let's name it as web Azure backend. Add. Let's go to the configuration. Now the front end and backends are ready. To set up the communication between the front end and backend, routing rule has to be created. So let's create a routing rule. Web Azure default rule. Priority, let's give the priority as 10. Listener name, LST, web Azure default. So the listener is assigned to the front end IP of application gateway. We are not using any TLS or certificates here. So we'll use the HTTP port, which is port number 80. And the type will be basic because we are not using multiple custom domains here. Let's go to the backend targets. In the backend pool, let's select the backend, web Azure backend. And there are no backend settings already created. So let's create a new one. So backend setting default web Azure. And in the backend protocol also we are going to use HTTP because we haven't installed any certificate or enabled any TLS on the backend servers. We are not enabling any session affinity or connection draining. Let's leave everything default and add. Now the backend setting is added. And this is the place where the path-based routing can be set up, which I'll show after the deployment of application gateway. Let's add. So now front end is aware which backend pool it should talk to using the routing rule. We don't need tags for this. Review and create and create. It will take a couple of minutes to create application gateway. I'll pause the video and we'll be back once application gateway is created. It took around 10 minutes and now application gateway is deployed. Let's go to the resource group. And here you go, application gateway is deployed now. So let's go to the application gateway. It's in app gateway subnet. It has a front-end IP address. So let's check the configuration. We didn't enable auto scaling as you can see here. Backend pool is already created with the two targets. Web Azure 01, 02. Front-end IP address, this is the public IP address. And there is a listener which is attached to the front-end IP, as you can see here. And there is a rule, which is basic HTTP rule created so that any traffic hitting to the front-end IP can reach to the backend server. So let's check the public IP of the application gateway and see if it's working properly or not. Copy this IP. and perfect. As you can see, it's showing this is a default page for Web Azure 01. And if we'll keep hitting this, it should load balance between Web Azure 01 and 02. And as you can see, after a few tries, it's now load balancing between Azure 1 and Azure 2. So now, instead of using the IP address, let's use the custom domain. And let's map this IP to the custom domain in DNS zones. Let's go to DNS zone. DevSecOps tech.online. Create a record set. No need to provide anything, just the IP address. Okay. An A record will be created, alias record will be created for this. So now let's try to reach DevSecOps tech.online. And as you can see, it's load balancing between Azure 01 and Azure 02. Now let's move on to the path-based or URL-based routing. So till now, when a request is coming to the front-end IP of the application gateway, it's getting directly rerouted towards the backend pool. But in the case of the path-based or the URL-based routing, application gateway will smartly check the URL in the request header and then decide which backend pool it should go to. So as in this lab, if the URL has Azure in it, then it will go to the Azure backend pool. And if it has AWS in it, then it will go to the AWS backend pool. So let's try to deploy the similar setup in Azure portal. So before making changes to application gateway, I'll make the web servers ready so that they can show a web page when the path has Azure or AWS in it. So let's go to Web Azure 02. I'm already logged in. I'll go to the IIS location, which is C inetpub www root. Let's create Azure folder and copy the files which I have already created. So let me copy the files. There is one JPG file or Azure Cloud, which you can see now. It'll just show an image. And another one is an HTML file which just open this image. So let's open it with Notepad. And as you can see, it's just showing the image source. So let's copy these two files into the new location, which is in folder Azure. And let's check in the local web browser if the new setting is working or not. If we'll go to the local host, it'll show the default page. But if we'll type the path azure.html, it shows the new web page. So that's good. And for saving time, I have already set this up in Web Azure 01 and Web AWS 01. So now we are ready to make changes in Application Gateway. Let's go to Application Gateway. First, let's create one backend pool. Add Web AWS backend virtual machine and Web AWS 01. It will add the network interface card of the virtual machine. Backend pool is created now. We don't need to make any changes to backend setting because we are going to use the port 80 HTTP port. There will be no change to the front-end IP too, because front-end IP is mapped to the custom domain and we are using the same custom domain for testing. Let's go to the listener. There is one limitation with the listeners that we can't create multiple listeners with the same public IP and port. And this default listener is already attached to the default rule. So to create a new rule, we need to make the changes in this listener so that we can create another listener with the port 80. So let's change it to port 8080 and save. So that means now if we'll go to our custom domain devsecops.tech.online, it should not work because the port number is changed from 80 to 8080. Let's wait for a few minutes till these changes are reflected. Now the changes are applied and listener is updated. So let's go back to our custom domain. It will still not work. Let's use the port 8080 and it's showing the default page now. And it's load balancing between Web Azure 01 and 02. Let's go back to our listener, add a new listener. And this time we'll path-based listener. Port 80, public IP, all the settings are same. Now let's go to the rule. We'll create a new routing rule. Rule name is path-based rule. Priority, let's give the priority as 11. New path-based listener. And for the backend targets, let's add web AWS backend. And we can use the same backend settings. Now in the case of the path-based routing, we need to add multiple targets. So let's add multiple targets. Azure star. So that means if in the URL there is Azure, it should go to web Azure backend. Azure path. The backend setting, same backend setting we can use. Add another one. Now this time we'll add AWS star. Backend will be web AWS backend. Same backend settings. And AWS path will be the name. Add. And now we have added the path-based rules. Add. And this will start making the changes into application gateway. Let's wait till all the changes are applied. We'll see how our custom domain URL is reacting to the new changes. Application gateway is updated now. And there is a path-based rule created now. So let's go to devsecops.tech.online, Azure, and azure.html, the page which we have created. And perfect. As you can see, this was the page which was created for this path. Now let's change the path to aws.html. And now it shows the HTML page for AWS server. To conclude, in this video, we deployed application gateway and set up the basic routing, which uses only a single backend pool. And later, we have configured the path-based routing, which uses multiple targets. And this shows application gateway is a smart web-based load balancer, which checks the URL of the request and does the routing accordingly. That's it for this video. In this video, I'll show how to set up TLS or SSL termination in application gateway. However, instead of using the self-signed certificate, I'll be using the Let's Encrypt CA signed certificate. So let's start with the introduction first. What is TLS termination? So it is a process of terminating the TLS encryption of incoming HTTPS request at the application gateway. And then the request will be passed on to the backend server in an unencrypted form. Application gateway acts as an intermediary where SSL or TLS certificate is used to decrypt the incoming HTTPS request. So the benefit of using TLS termination with application gateway is that it can offload the resource intensive task of encryption or decryption from the backend servers, which overall improves the performance and scalability of web applications. However, application gateway supports end-to-end TLS encryption, but in this case, I'll be talking only about TLS termination. Now let's set up the TLS termination in the lab. I have pre-created the resources used for hosting the Windows IIS server using application gateway. There is one virtual machine which is created. As you can see, web server 001. It's a Windows 2019 server. I have installed an IIS role in it, which shows the default IIS page. I'll RDP to the web server, and if I'll open the browser, localhost, as you can see the default page for IIS. And if I'll show the IIS manager, this is the default setup, no changes has been done here. It's a default website which is created when you install the roles using Server Manager. So let's go to Application Gateway. An Application Gateway is created where a backend pool is created with the name Web Server Pool. And in the backend pool, the same web server is added here. For the backend settings, there is a setting for port number 80, which is HTTP. So right now our web page will be listening only on the port 80, which means HTTP protocol. For the front-end IP, there is a public IP configured for Application Gateway. If we'll go to the listeners, there is a web server listener which is created, and it's also listening to the port 80 on HTTP for the front-end public IP of load balancer. And finally, the rule which is created. So for the listener which is listening to the port 80 on the front-end IP of the load balancer goes to the backend pool, web server pool. So this is the very basic configuration which has been done on Application Gateway. And if we'll just open the public IP of the Application Gateway, it will show the default web page. And as you can see, the default page is visible now using the front-end IP of Application Gateway. To set up the TLS termination, we need a domain name, and I have created one DNS zone with the domain name which is already registered with me. There is a domain name devsecopstech.online, as you have seen in the previous video too. An alias record is created for the front-end IP of the Application Gateway. So that means if we open the devsecopstech.online, it shows the same default page which was showing for the front-end IP of the Application Gateway. And when you view the site information, you see that this site is not secure because it's using HTTP protocol, which is port 80. So to make it more secure, we'll now install the TLS certificate in Application Gateway, and for any incoming request from the browser, all the TLS termination will happen at Application Gateway itself. However, from Application Gateway to the backend servers, the connection will still be non-secure and it will use the protocol HTTP, which is port 80. If we use the self-signed certificate for the TLS termination, then every time a new connection is established from a browser to the Application Gateway, the self-signed certificate has to be trusted by the browser. However, to make it more real, I'll use the Let's Encrypt CA signed certificate. So as you can see, this is the Let's Encrypt website, and they are a non-profit certifying authority which provides CA certificates for free. Let's Encrypt uses ACME protocol to issue a certificate. There are multiple third-party clients which are available to generate the certificates. The most recommended is Certbot. However, this works well in Linux-based servers, and we have Windows IIS server. So for that, WinACME works well, which works on .NET. So I'll be using WinACME for generating the certificate. So let's go to our web server. Open the browser, type win-acme.com and download the latest WinACME. Save it, open folder and extract everything. Now this is the application. Let's run this application. We have to trust it, run anyway. Now we can create a certificate using the default settings. But in this case, we don't want to use the certificates on this Windows server. We want to generate the certificates and use on the Application Gateway. So for that, we'll use full options. Let's type M. And read bindings from IIS, yes. Let's press enter because one is already selected. But there is one problem. It's telling that no website with the host bindings has been configured in IIS. So for this, let's open the IIS manager. and let's check the bindings. And as you can see, there is no binding, but we want to generate this certificate for our domain name. So let's provide the domain name here. Okay, close. Let's go back, try again, type M, read the bindings, and now it shows that there is a default website. Let's select this, pick all the bindings, and from the bindings it has found that it's for the domain devsecopstech.online. Yes, so just type enter. And we want to use the single certificate because Application Gateway only accepts a single certificate. Yes. Sub verification file from the memory. Yep. RSA key. Instead of saving the certificate in Windows Certificate Store, we'll just use the PFX archive because we want to generate a PFX file. The reason why we are not using the Windows Certificate Store is because when we export the certificate from Windows Certificate Store, it doesn't let us export the private key. So use 3. So let's get the C drive itself. Set up a password. Number 2. We'll type the password now. Now we don't want to save it in Vault. No additional steps. We are done. We don't want to open it. We agree. This is just a demo, so I don't need to renew it. If you're using the certificate which has to be renewed after 90 days, then provide your email address so that you will be notified when your certificate will be expiring. I'm not providing anything here. And done. It will generate a certificate for me. And as you can see, PFX file is generated, which is in C drive. So let's quit. Close this and open the File Explorer, C drive, and here is the certificate. This is a PFX file which we'll upload in Application Gateway. Now to get this file out of the web server, I have created a Azure Storage file share account. So there is one storage account which is created for this, st file share, and if you'll go to the file share, there's a share drive. Let's copy this information. Open the run. Change few values. And provide the credentials. I'll be using the access keys. Let me copy the password separately. And here you go. The share drive is open. Now I'll copy the certificate to this share drive. It's done. Let's close everything. Close the RDP session. I have to sign in again. So let's go to the storage account again. File share. Share drive, browse, and download this. Let's check the folder. And I have the PFX file in my laptop. Now let's go to Application Gateway. There will be no change in the backend pool because we are using the same web server. There will be no change in the backend settings because, as I mentioned, this is TLS termination, not end-to-end termination. So the connection between Application Gateway and the backend server will still be HTTP, which is port 80. Let's go to the listener. Let's create a new listener. Copy this name, use 443 or HTTPS. I'll use 443 here. HTTPS, it uses 443 port. Upload a certificate. Let's give the certificate name as DevSecOps tech. Upload the file, downloads, and provide the password. And everything else will be default. Add. Now there are two different listeners, one for port 80, one for port 443. Now I'll create a different rule for port 443. Create a routing rule. Let's copy the name from here. 443. Set up the priority as 8 because it was 10, so I'm just setting it up 8. Select the listener as 443. For the backend, backend pool will be the same, backend setting will be the same. Add. It took a minute or two and now the settings are saved. There should be two rules now. And let's go to DevSecOps tech.online. Let's use HTTPS here. And as you can see, it's secure now. Because security is provided by the Let's Encrypt CA signed certificate. But there is still one problem. If we'll use the port HTTP for this domain, it shows as not secure. To change this, what we can do is we can set up the redirection on port 80. Let's go back to Application Gateway. And for the routing rule, which was for the port 80, let's go to the backend targets. And instead of going to the backend pool, let's set up a redirection, which is permanent, and the target listener will be 443. So that means if anything which is being listened on port 80 will be moved to different listener, which is listening on port 443. Let's save this. It will take a couple of minutes to save this. It's all done. And if we'll go to the website, refresh it, now it's secure. So if we'll try again for the HTTP, it'll go back to the secure. So that means if it's HTTP, it'll be redirected to HTTPS automatically. To summarize this video, first we have generated the Let's Encrypt CA signed certificate using WinACME. Then we created the new listener for port 443 and uploaded that certificate there. After making the new rules for port 443, now our website, which is devsecopstech.online, is using HTTPS protocol and is secure. However, you know that the connection between application gateway and the backend server is still non-secure. And I'll create a separate video for end-to-end encryption of application gateway. That's all for this video. And in this video, I'll show how to set up multi-site hosting in application gateway. So let's start with the explanation of what is multi-site hosting. It's a feature that enables a single Azure Application Gateway to host multiple websites or web applications, each with its own domain name. So that means you don't need a separate application gateway for different domains which you are hosting in your environment. And the benefit of using multi-site hosting is the easy management of resources as well as simplified way of setting up SSL or TLS termination. In my experience, I have seen that most of the organizations keep one application gateway for different environment like prod, non-prod, and test. So that means in the prod environment, there will be a single application gateway which will host all the web applications in the prod environment. And the reason for keeping the separate application gateway for each environment is because you don't want to make changes in the production application gateway because of the frequent changes you are doing in the test environment. And apart from this, you can also set up path-based as well as the host-based routing for multi-site hosting in application gateway. In this lab, I'm using two different domains, devsecopstech.online and shailendra.online. I have registered these two domains in GoDaddy and I'll be using them as a DNS zone in Azure. There are two web servers which are created for this lab. One web server will cater the traffic for devsecopstech.online and the another web server will cater the traffic for shailendra.online. Both of these web servers will be placed in a separate backend pool, and using the routing rule in the application gateway, all the traffic for these two different websites will go to their respective backend pool. I have pre-created few resources Let's go to the virtual machine. And there are two virtual machines which are created. One for devsecops.tech.online and another one for shalendra.online. So both of these virtual machines are Windows 2019 servers and IaaS feature is enabled on them. And a default web page is created which shows the name of the server. And if we'll go to the DNS zones, there are two different DNS zones which are created, devsecops.tech.online and shalendra.online. Right now there is no alias record which is created, which will create after the creation of application gateway. So let's create one application gateway. Create. We'll select the resource group RG Dev Application Gateway. It's already created where the virtual machines are lying. Let's name this application gateway as AGW Dev 01. The region will be Australia East and we are using the version 2. Let's not enable the auto scaling and we just want instance count as 1. And for the virtual network, there is one virtual network where all the virtual machines are also lying. An application gateway, as you know, requires an empty subnet. So an application gateway subnet is also created for it. Let's go to the front ends, create a new front end IP, AGW public IP. Okay. Let's go to the backend. Let's create two backend pools. Let's name the first one as backend DevSecOps Tech. For the target type, it will be a virtual machine which is already created. And here is the NIC card for that virtual machine. Add, create another backend pool. Backend pool shalendra. Virtual machine. And this time it will be the NIC card for the shalendra virtual machine. Add. Now two backend pools are created. Let's create the routing rules now. Start with the routing rule for DevSecOps Tech rule. The priority is 10. Let's copy the name. Listener. For this lab, I'll be using only HTTP protocol. And if you want to understand about the TLS termination and want to use the HTTPS protocol, I have provided a link of TLS termination in the description of this video. The listener type will be multi-site and I'll select single DevSecOps Tech.online. In the case of the multiple or the wildcard, you can provide the star if you have multiple host names like images.devsecopstech.online or videos.devsecopstech.online. So in that case, you can use the wildcard. But we have a single website with a default page, so I'll be using the single. Let's select the backend targets, select the pool, and create a new backend setting. DevSecOps Tech setting and add. Let's create another routing rule. Shalendra.rule. Priority is 11. Listener /listener. It's for the same frontend IP. We'll be using the HTTP protocol and multi-site. Shalendra.online. For the backend target, this time we'll select another backend pool Shalendra. And you can use the same backend setting or create a new one. Let's create a new one. Shalendra setting. Add and add. Now for the same front-end IP, we have created two different routing rules with two different backend pools. Next, review and create, and let's create. This will take around 5 minutes to create application gateway and configure it. I'll pause the video and we'll be back once it's done. Application gateway is created now. Let's check. Go to the resource group. Application gateway. This is the public IP of application gateway. This is the application gateway. If we'll check the backend pools, there are two backend pools. Backend setting, there should be two different backend settings. We can use one also in this case, but because we are creating everything separate for two different websites, so we created these two different settings. Front-end IP, there is only one public front-end IP for the application gateway. So if we'll check the listeners, there are two listeners which are listening on port 80, and if we'll check the rules, there are two different rules created for it. So now to use the website, we have to create the alias record in the DNS zone for both the website against the public IP of application gateway. So let's copy the public IP first and go to DNS zones. Let's make changes to devsecops stack.online. Provide the public IP and OK. Oh, sorry, there is a space. Okay. Now we'll do the same thing with shailendra.online too. Create a new record set. Provide the IP. And OK. Now let's check those websites in the browser. devsecops stack.online. And here you go, the web page for devsecops stack. And this is coming from the web server devsecops stack. Now let's check another one, shailendra.online. And now this is also showing the web page from the web server Shailendra. To summarize this video, using the multi-site hosting, multiple domains or the multiple website can be hosted using a single application gateway. Both of these websites will have different listeners, different routing rules, and the different backend. And you can set up the TLS termination, set up path-based routing or the host-based routing. So that means a single application gateway can be used to host all the websites in your environment. That's all for this video. And in this video, I'll explain the custom health probes in Azure Application Gateway. So let's start. In Application Gateway, a health probe is a feature to regularly check the health of the backend servers. So Application Gateway regularly sends the request and then evaluate the response to make sure the traffic is directed to the healthy servers. And it is important because if there are no health probes, then the Application Gateway will keep on sending the request or the traffic to unhealthy backend servers, and there will be a traffic loss, and which will impact the reliability and the performance of applications. So by default, Application Gateway creates the health probe on port 80 and 443, which is HTTP or HTTPS. And it is based on the port or the protocol which the backend servers are listening on. So if the backend server or the web server, you can call it as, is listening on port 80, then automatically a health probe will be created, which will regularly checks on port 80. And if it's listening on port 443 or using the protocol 443, then the application gateway health probe will continuously monitor the backend server on port 443. Based on the frequency and the timeout, application gateway will flag the backend server if it's not listening on port 80 or 443. So now if we'll talk about the custom health probes, they provide the ability to customize the health checks based on application specific needs. You can set up the custom health probe based on protocol, port, path, or the response criteria. Response criteria means which type of response you're getting when you're hitting the URL. Based on the response criteria, Application Gateway can accurately monitor the backend and then direct the traffic to the healthy backend servers. So let's check this in lab. To focus on custom health probes, I have already created the setup of Application Gateway along with the backend resources. So let's go to the virtual machines. And there are two virtual machines which are created. Both are 2019 Windows Server and they are running IIS. But instead of using the default IIS page, I have created a basic HTML page. Let's go to Application Gateway. There is one application gateway with the name AGW dev01. And it's a version 2 application gateway. In the backend pool, there is one backend pool which is created, but it has two servers which I have created, Web Server 1 and Web Server 2. If we go to the backend setting, both of these servers are listening on port 80, which is HTTP protocol. For the front-end IP, there is a public IP configured for Application Gateway, which is mapped to the domain name devsecops stack.online, which I have been using throughout the whole series. If I'll go to the listener, a listener with the name web server listener is created and it's listening on port 443. I have uploaded the certificate for devsecops.tech.online and it's mapped to the front-end IP of the application gateway. And if you want to know how to set up the TLS termination in application gateway, you can check one of my previous video and I have provided the link of that video in the description of this video. If we check the rules, a rule is created where the listener is mapped to the backend pool using the backend settings, which I have already shown you. And let's go to the DNS zone. And for the DNS zone, devsecops.tech.online, I have created an alias record for the front-end IP of the application gateway. So this is the whole setup where the load balancing will happen between web server 1 and web server 2. Let's open the URL devsecops.tech.online and if we'll keep refreshing it, it's load balancing between server 1 and server 2, as you can see. Now let's go to the application gateway and check the health probes. Right now there is no health probe created, but that doesn't mean that application gateway is not monitoring the backend servers. As I've already explained, by default application gateway monitors the backend server on port 80 or 443 based on what the backend servers are listening on. So let's go to the monitoring and the backend health. It takes few seconds to refresh it. Let's wait. As you can see, both the servers are healthy and they are listening to port 80. Now let's test the backend health by making changes to the backend web servers. Right now I have RDP into the web server 01. Let's open the IIS manager. This is web server 01 and stop the service. Now let's go to the URL devsecops.tech.online. And as you can see, it's still waiting for the page to load for web server 01. However, if you'll refresh again, it'll load the web server 02 because the Azure Application Gateway is still load balancing between these two servers. Now let's go to the application gateway and check the backend health. Refresh. As you can see, it's still showing it healthy, but the response which is getting is 503, which is an issue with the backend server. And you would be thinking why it's showing healthy. The reason is because by default, it retries for 3 times with the timeout of 30 seconds and frequency of 30 seconds. For certain amount of time, there will be a packet loss, but eventually after some time, the application gateway will be aware that there is an issue with the backend server and it will stop redirecting the traffic towards that backend server. So let's check again. And the URL is showing the gateway timeout now. If we'll refresh again, it will redirect to web server 02. Refresh again. Now application gateway is aware that web server 01 is having some issues and it's not redirecting the traffic there. And on the backend health page, Azure Application Gateway has marked it as unhealthy. And now no traffic is being redirected towards the web server 01. Let's restart the service again. And let's check. Now it's redirecting between 01 and 02. And if we'll refresh the backend health, it will show that both servers are healthy. Perfect. But in the case of the production or the enterprise level, not all the web server listens to port 80 or 443. Sometimes there is a custom port which is created for specifically for that web application. And there is one more problem. And in some scenarios, the web server is listening to port 80 or 443, but it's not loading the web pages. Let me show you. Let's go to web server 01 and go to the path, C drive, inetpub, www.root. And this is my page, which is web server 01, first web server. This is the HTML page which is created. Let's move this HTML page from here to some other location. Any location you can move it to. Let's go back to devsecops.tech.online. And now you can see instead of web server 01, it's showing the default web page of IIS and it's load balancing between the two different servers. In this scenario, application gateway will think that the backend server is fine and it's listening on port 80 or 443, but actually it's showing the wrong information, which is not the correct web page. So this is the reason custom health probes have to be created for this. Let's revert back the changes and move it to www root. Let's refresh. And now you can see it's working fine. Now to make sure Application Gateway monitors the path as well as the port of the backend server, so we have to create the new custom health probes. So let's add a custom health probe. Name it as web server probe. The backend server in this lab are listening on port 80. So I'll select the protocol as HTTP. There's an option to pick up the hostname from the backend settings, but because we are using the multiple servers in the backend pool, so we need to provide the domain name here, devsecopstech.online. Pick up the port from the backend settings, which will be port 80. But in case if your web servers are listening on a different port like 8080 or any other port, you can mention it here. For the path, Application Gateway should look for mypage.html file in the root folder, which is www root folder. Let's reduce the interval to 10 seconds, timeout as 10 seconds, and unhealthy threshold as 1, so that Application Gateway will quickly figure it out and flag the backend server and stop redirecting the traffic towards that backend server. In the probe matching condition, by default 200 to 399 status code is provided. However, you can add different codes and provide an exemption. This is done usually in the cases where there is a certain file and only authorized user have access to that file. So in this lab, I'm selecting it as no. Select the backend setting, which is web server setting, and let's test it. An application gateway has found mypage.html in both the servers, and both the servers are healthy for now. Add. So now Application Gateway has custom health probes, which is monitoring on port 80 as well as the path. Let's go to the web server 01 and try to move the web page again. Let's move this page to any other location. And let's check the URL. Now again, it has started showing the default page because the actual web page is moved. Because the interval is 10 seconds, Application Gateway should quickly flag the backend server as unhealthy. Now you can see the backend server is showing as unhealthy because it's providing the status code as 404. And if we'll go to the custom health probes and test it from here, it is also showing that one of the server is unhealthy. So let's go to the web page. And now the Application Gateway is not load balancing between web server 01 and 02, and it's just providing the web page from server 02. So let's go back to the web server 01 and move the page back again to its actual location. Let's go back, test it again, and this time it should be fine. And as you can see, now Application Gateway is able to locate mypage.html for both the servers. And if we'll go to the URL, now it should load balance between both the servers. As you can see, web server 01 and 02. So to summarize this video, a health probe is a feature in Application Gateway which regularly checks the health of the backend servers. By default, Application Gateway monitors only port 80 and 443 of the backend servers, which is sufficient if we are testing in a lab. But in the case of the production or enterprise environment, different applications have different requirements. And in the custom health probes, monitoring can be done based on protocol, port, path, and the HTTP response of the backend servers. So that's all for this video. And in this video, I'll show how to set up end-to-end TLS encryption in Application Gateway. However, instead of using the self-signed certificate, I'll use the CA signed certificate from Let's Encrypt. So let's start. Application Gateway supports both TLS termination as well as end-to-end TLS encryption. So in the TLS termination at the application gateway, TLS encrypted traffic is first decrypted at the gateway and then the traffic flows unencrypted to the backend server. While in the case of end-to-end TLS encryption, all the data which is passed between the web server and the browser of the users remain private and encrypted. Hence, it provides the security for the entire journey of the data, starting from the client to the backend server, which maintains the confidentiality and integrity. The architectural diagram on your screen is showing the unencrypted flow of traffic from the user till the backend servers, where application gateway is in the middle. In this lab, I'll be using the custom domain as shailendra.online. So as you can clearly see in the diagram that the user, when they are hitting shailendra.com in the browser, then the traffic will go unencrypted using the protocol HTTP. And then the application gateway will forward the traffic to the web servers using the protocol HTTP itself. So that means there will be no encryption in this setup. But in this lab, we are going to set up end-to-end TLS encryption, where the traffic from user to application gateway and from application gateway to the web server will be encrypted. So if the traffic from user to the application gateway is encrypted, that is called as TLS termination. But in the case of TLS termination, the traffic between application gateway to the web server will be in clear text or plain text form. In the case of the end-to-end TLS encryption, the data is encrypted from user to the backend servers. So we'll be using Let's Encrypt CA signed certificate, and we need to set up the certificate both on application gateway as well as the web servers, because we want to make sure that web servers are listening on port 443. Otherwise, application gateway can't transfer the data over port 443 to the web servers. So let's set this up in lab now. I have pre-created resources like web servers and DNS zone for custom domain. So let's check the virtual machines. There are two virtual machines which are created, web server 01 and web server 02. If we click on web server 01, it's a 2019 server and I have installed IIS on this and created a default HTML page. If I'll quickly RDP to this server and open the local host, you can see it shows the name of the server. And if we'll try HTTPS, it will not work because it's only listening to HTTP right now. Same is the case with the web server 02, which is a 2019 Windows Server 2 and IIS is installed on it. And if I'll RDP to the web server 02 and open localhost in the web browser, and it should show the name of the web server. And apart from this, there is a DNS zone which is created. Let's focus on shailendra.online because I'll be using this one in this lab. It's showing the previous alias record, but when we have the application gateway set up, and we'll change the alias record for shailendra.online to be pointing towards the public IP of application gateway. So let's create an application gateway without TLS termination or end-to-end TLS encryption. And then we'll generate the certificates which we'll use for HTTPS protocol. Let's create application gateway. Go to the application gateways, create a new one. I'll select an existing resource group, RGDev application gateway. Let's name it as AGW Dev 01. Region is Australia East and we are using the version 2. Let's disable the auto scaling and make the instance count as 1. No need of availability zone, and let's select the network and application gateway subnet. It's already selected because I have a virtual network with the application gateway subnet. The condition for using the application gateway subnet is that there should not be any resource created in that subnet. Let's go to the front end, create a new IP, AGW public IP 01. Okay. Create a backend server, web server pool. Select the virtual machines 01 as well as 02. Add. And in the configurations, Let's create the routing rule. Web server rule. Let's give the priority as 100. Web server listener. Frontend IP to be the public. And for now, we will be using HTTP protocol. For the backend target, select the backend pool and create a new backend setting with HTTP protocol and port 80. Web server setting, add. Now the frontend IP, routing rules and the backend pool is created. Next, review and create and create. Creation of application gateway takes few minutes. So I'll pause the video and we'll be back once it's done. Application gateway is created now. Let's go to the resource group and go to the application gateway. And you can see a front-end public IP address of application gateway. It's in the subnet application gateway subnet. If we look at the backend pool, there is one backend pool with two targets, which are the two virtual machines which we have created, web server 01 and 02. Backend settings, right now we are using HTTP protocol with port 80. Front-end IP, it's the public front-end IP. For the listener, it's listening on port 80, which is protocol HTTP. And there's a basic rule which shows that the listener which is listening on the front-end IP should go to the backend target using the specific backend setting which we have created. Let's grab the front-end IP address and then go to the DNS zone. I'll update the alias record with the new IP address. Save. Let's check the URL shailendra.online. HTTP. And it's showing web server 01, 02. And now the application gateway is load balancing between server 01 and 02. But as you can clearly see, it's showing as non-secure because we are using protocol HTTP instead of HTTPS. Now to set up the end-to-end TLS encryption, I'll generate the certificates using one of the web server itself. I'm in web server 01 and this is the IIS manager for web server 01. Open WinACME in web browser. So WinACME is a client for Windows which is used to generate the Let's Encrypt certificate. Let's download it. Save. Extract everything. And run the application WACS. Run anyway. There are multiple ways you can create the certificate using the default setting as well as the full options. Using the default settings, the certificate goes into Cert Manager and most of the times the private key is not exportable. So what we'll do in this case is we'll use the full options M and generate the certificate in the PFX format. Read binding from IIS. But right now there are no bindings. So we'll provide the bindings now. M, manual input, shailendra.online. We want a single certificate. Provide the verification from the memory, RSA key. The default option is Windows Certificate Store, but instead of that, I want to create the PFX format. Select option 3. File path, let's save this in C drive. Number 2, so that we can provide the password. We don't want to save it to Vault. No additional steps, no additional installation. No, and agree to the terms. Because this is a lab and we don't want to renew these certificates, so let's not provide the email address here. And the certificate is created now. As you can see, it's in C drive, shalenderonline.pfx. So let's go to the C drive. And here is the certificate. As I have shown in the slide, that the certificate will be installed or used at two places. One is Windows IIS server, another one is Application Gateway. So we'll install this certificate for both the web servers, 01 and 02. Let's do it. Let's open IIS Manager. Go to the web server, server certificates, import, get the file from the C drive. You have to provide the password. Okay. Now let's go to the default website or the website which you have created for your server. Click on the bindings, add a new binding for HTTPS. Select the certificate, shalender.online. Okay. Close. Open the web browser. Localhost. So instead of using HTTP, let's use HTTPS. And you would be thinking why it's still showing untrusted certificate, because we generated certificate for shalender.online, not localhost. But because shalender.online is not mapped directly to the web server, there is application gateway in between. So once we'll set up everything, and finally when we'll use the shalender.online, it should show end-to-end encryption and HTTPS should be shown there. Now we have to repeat the same steps for web server 02. But for this, we need to take this PFX file certificate out of this web server. And for this, I have created a file share storage account. Let's go to the portal first. Storage account. There is one storage account which is created for this purpose, file share, with the name share01. Let's copy this and open in the web server. It'll prompt for username and password. Let me move this so that I can copy the password. Username is the name of the storage account and password is the access key. Let's copy this and open the same thing in that another web server 02. Provide the username, password, and copy the file to the C drive. Let's open IIS Manager for web server 02. Go to the server certificates, import the file, provide the password. Okay. Now let's go to the default site, create a binding for HTTPS. Open the web browser. For HTTP, it's working fine. Let's check HTTPS. And it's showing as not secure, but still showing the web page as HTTPS because the certificate generated is for shalender.online. Now our both the web servers are listening on port 443 and using protocol HTTPS. Let's go to the application gateway now and get the storage account too. Let's download the file. File is downloaded now. Let's go to the application gateway. So let's go to the backend setting to create a new backend setting for protocol HTTPS and port 443, because now our servers are listening on both port 80 and 443. Add a new setting. We'll use HTTPS. So backend server certificate is issued by a well-known CA because it's Let's Encrypt. So I'll select yes. But in case if you're using the self-signed certificates, and you can provide the root certificate here. But in this case, I'll select as yes. We are not enabling any cookie-based affinity or connection draining. So let's save this. So let's create a new listener for HTTPS. For the front-end public IP, select HTTPS, upload a certificate. Let's provide name as shailendra.online. File, let's get it from the downloads. I'll provide the password. Basic listener, we are not using multi-site, and add. Now we have created two backend settings and two listener. And as you can see, for the new listener which we have created, there is no rule associated. So let's create the rule. Web server rule HTTPS. Let's set up the priority. It was 100, so let's set it up as 90. Listener as HTTPS. Backend target to the same backend pool, and we'll use the backend setting as HTTPS setting, and add. So once the changes in the application gateway are saved, we'll open shailendra.online in browser. Changes are saved now. Let's refresh the page. And now there are two different rules with two different listeners and two different backend settings. So let's open shailendra.online first. And it's fine because we are using HTTP. Let's change it to HTTPS. But we got an error that it's a bad gateway. And that means application gateway is not able to contact the backend servers on port 443. So let's go back to application gateway, backend setting, HTTPS, and we have to make changes to the host name because the certificate which we have provided here is a well-known CA certificate, but it is generated for shailendra.online, not web server 01 or 02. So override the new host name. Let's provide shailendra.online and save. Now the changes are saved. Let's go back again and refresh the page. And as you can see, it's showing as web server 01 and 02. It's load balancing between them. And the connection is secured because we are using the CA signed Let's Encrypt certificate. To summarize this video, we first created two Windows web server 01 and 02 and then installed the IIS server on it. Later we generated the certificate using Let's Encrypt on one of the Windows server. And on server 01 and 02, we imported that certificate. And those web servers started listening on port 443. On application gateway, we made changes in listener, backend setting, and the application gateway rules, where we provided the certificate and made changes according to protocol HTTPS. Because the certificate was generated for shailendra.online, so when we open shailendra.online using HTTPS protocol in the browser, the connection is secure end-to-end from browser till the web server. So that's all for this video. In this video, I'll show how to deploy a web application using the app service and Azure Application Gateway. So let's start. Multiple components and the features will be deployed in this lab as you can see on the slide. I'll start with the deployment of app service plan using which a web application will be created in app service. I'll use the framework as .NET and deploy a sample ASP.NET web application which will be created using Visual Studio. And once the web application is hosted on the app service, I'll create the Azure Application Gateway version 2, where the front-end IP configuration, listener, backend pool, backend setting, and routing rule will be created. The backend pool will have an app service which will be created for ASP.NET. And in the backend settings, I'll use the protocol HTTP. So that means the traffic from application gateway to app service will be unencrypted and use protocol HTTP. However, during the creation of the listener, I'll upload a certificate for the custom domain shailendra.online and use the protocol HTTPS, which means the traffic from the user to the application gateway will be encrypted and will use port 443. And once application gateway is ready, there will be certain integration and configuration changes that have to be done so that app service can be integrated to Azure Application Gateway. However, you would be thinking that when we deploy virtual machine in the backend pool for the Azure Application Gateway, there are no certain changes has to be done. But because app service is a platform as a service, so there are some integration that has to be done on the virtual network level. So let's go to Azure portal and start with our deployment. Right now there is no app service plan deployed. So let's create a new one and create a new resource group, RG backend. Let's name it as ASP dev 001. The operating system will be Windows and the region will be Australia East. There are multiple pricing plans which are available. Let's explore the pricing plans. So I'll select the standard S1. Let's go to tags. We are not creating any tag. So let's review and create. So app service plan is created now. Go to the resource. And you can see it's a S1 plan. Now let's go to app service and create a new web app. We'll use the same resource group as RG backend and name it as Shailendra, and the URL will become shailendra.azurewebsites.net. We'll use the code, select the runtime stack as version 4.8, ASP.NET version 4.8. Operating system will be Windows and Australia East will be the region. I'll use the same app service plan which I've just created. There is no need of any database because we are just deploying a sample ASP.NET application. We don't need any CI/CD pipeline, and for now we'll enable the public access. No monitoring is needed. This is just a lab and I'll delete everything after this video is completed, so no need of tags here. Review and create. And I'll be back once the web application is ready. It took around a minute or two and now web app is created. Let's go to the resource, and as you can see, and the web app is created now. And it's using the service plan S1 with the default domain as shailendra.azurewebsites.net. So let's open this. And it's just showing the default page. Let's open Visual Studio and create a sample ASP.NET application. Create a new project. It will be ASP.NET Core Web App. Next. Let's name it as Web Application 1 and I'll provide the location where it will be saved. Next. I'll use the .NET 8.0 long-term framework. There is no need of HTTPS because in the backend setting we'll be using protocol HTTP and the traffic between application gateway and the app service will go unsecured. So Visual Studio is creating the project now. So the Visual Studio provides an option where you can locally deploy the application and see how it looks like. So let's deploy the application. And this is a temporary deployment. Once you'll close the browser, automatically it'll reset. And it's using port 5233 on the local host. So let's make some basic changes so that our website looks like a custom website for us. Let's go to pages, index.html. Actually, it's index.cshtml. Make some changes. Welcome to web app, Azure service. And let's remove this line. Save. Let's redeploy and check how it looks like now. So as you can see, it's showing welcome to web app Azure service. And now I'll publish this sample web application into Azure. So let's go to publish. So there are multiple options. You can deploy locally on a web server, IIS server. You can save it in a folder. You can use the Docker, but I'll deploy in Azure. Next, because we are using Azure App Service Windows, I'll select that. Next. Now it's looking for the app service plans which are already created. So as you can see, RG backend is the resource group and Shalendra is the web app. So let's finish and deploy. Close this, profile is created and let's deploy. Actually, there is a mismatch between the framework which is used in web app and in the Visual Studio. Now Visual Studio is very smart and it will automatically fix everything for you. It has started the deployment of this sample web application into Azure App Service. And I'll be back once this is deployed. It took few minutes and now web application is deployed. As you can see, shalendra.azurewebsites.net and it's showing the custom web page which we have created. And Visual Studio is also showing us that it's successfully published. So let's cancel this. Now the next step is to create the Azure Application Gateway and we'll use the web app in the backend pool. So let's go back to portal, Application Gateway, create a new one. There is a resource group already present, RG Dev Application Gateway. I'll use this one, AGW Dev 001. The region will be Australia East. I'll use the version as version 2 and change the instance count to 1. No need of any availability zone and by default HTTP2 is enabled. Let's select the virtual network and there is a subnet app gateway subnet which is created specifically for application gateway. The condition for using the subnet for application gateway is that there should not be any resource in that subnet. Let's go to front end, create a new public IP, AGW public IP 01. Go to the backend, create a new backend pool, web app pool. Select the app service. There is a web app named Shalendra. Let's select this one, add. Now let's go to the configuration. Now the front end is created, backend pool is ready. Now we have to create the routing rules. Let's name the routing rule as web app rule. Give the priority as 100. Listener as web app listener. And instead of using the HTTP protocol, we'll use the HTTPS. In one of the previous video, I have generated certificate for shalendra.online using Let's Encrypt, which is a CA signed certificate. And you can find the link of that video in the description of this video. Shalendra.online is the name of the certificate. It's in downloads and let me provide the password. Now I'll go to the backend targets. There's a backend pool which is created and let's create a new backend setting. Web app setting. And because we have created the web application using protocol HTTP and we haven't provided any certificate, so the connection between Azure Application Gateway and app service will be using port 80 or protocol HTTP. Add and add. Now we have the whole setup with the front-end IP, listener, routing rules, and the backend pool. Next, review and create and create. Application Gateway usually takes around 5 to 10 minutes. So I'll pause the video and we'll be back once it's deployed. Application Gateway is deployed now. So let's go to the resource group and go to Application Gateway. Now because we'll be using the custom domain shalendra.online, so let's copy this public IP of Application Gateway and go to DNS zone. I have two custom domains with me. One is devsecopstech.online and shalendra.online. For this video, I'll be using shalendra.online and update the alias record here because I have been using this DNS zone for another videos too. So instead of creating a new one, let's update the existing one. Save. All set. Now let's open shalendra.online. But instead of getting the sample web page, we are getting the 502 bad gateway. Now there are certain configurations that has to be done on app service and virtual network so that application gateway integrates with Azure App Service. Let's go to virtual network. Go to service endpoints. And now we have to create a service endpoint for Microsoft Web so that the virtual network can connect to app service using the Microsoft backbone network. Add Microsoft Web, and application gateway subnet is the subnet where application gateway is deployed. Add, and this will create a service endpoint for virtual network. Now let's go to app service. And go to the networking section. Now let's make changes to inbound traffic access restriction. So now we'll add a rule where the subnet where application gateway is deployed will have access to app service. App gateway, allow rule number 100, or you can give any number. Select the virtual network and application gateway subnet. Add this rule. And if we'll be using shalendra.online to access the sample web application, we don't want it to be published using shalendra.azurewebsites.net. So now because of the unmatched rule action, everything which is not in the rule will be denied. And we can't disable the public access. The reason is because if we'll disable this, all the incoming traffic will be blocked apart from private endpoints. But we are not creating private endpoint in this video. So let's go back to application gateway and make the final change. Go to the application gateway and the backend setting. And in the backend setting, we have to override the new host name. And we have to pick up the host name from the backend target itself, which will be shalendra.azurewebsites.net. Save, and the application gateway changes are saved. And if you'll open shalendra.azurewebsites.net, it's forbidden because it's only accessible from application gateway right now. Let's open shalendra.online, and perfect. It's showing the sample web page which we have deployed on app service. To summarize this video, we have first created an app service plan where we deployed a web app on app service. We used Visual Studio to create a sample ASP.NET application and then deployed it in app service. Later, application gateway was deployed where front-end IP configuration, listener, rules, and the backend pool and the backend settings were created. Now this is the important part where we made some configuration changes so that the integration between app service and application gateway happens. First, we created the service endpoint in the virtual network for Microsoft.web so that the subnets can connect to the PaaS service using the web application. Later, the public access of the app service was disabled and the access was provided specifically to the application gateway subnet, due to which app service URL, which was shalendra.azurewebsites.net, was not accessible through internet. And finally, in the backend setting of application gateway, host name of the app service was overridden. And once these changes were done, now using the custom domain shalendra.online, the sample web application which we created in app service is accessible. So that's all for this video. So much. In this video, I'll show how to configure header rewrites in Azure Application Gateway. So let's start with the introduction of what are HTTP headers. They are the components of HTTP messages which are exchanged between the client. So the client can be web browser or a command terminal like curl or load balancer. They provide additional information about the request and the response which are provided by HTTP messages along with the type of content which is being sent in those messages. There are two types of HTTP headers. One is request header and the another one is response header. As you can see on your screen, the request header are the components of HTTP messages which are received from the browser to the application gateway. And the response header are the components which are being sent as a response from application gateway itself. So in application gateway, header rewriting is the ability to modify the HTTP headers of request and response when they pass through the gateway. And using this feature, application gateway can add, remove, modify the headers to meet the specific requirements or enhance the security of a web application. So let's check this in lab and configure header rewrite in application. I have pre-created the resources in the lab to support the header rewrite. First, I have created a web application in Azure App Service using the ASP.NET. And afterwards, this web app is added into the backend pool of Azure Application Gateway. If we'll go to the application gateway, there is one application gateway which is created with the name AGW Dev 001. And in the backend pool, the app service is added, as you can see here. The configuration of the application gateway is that the communication between the browser and the application gateway is secured using Let's Encrypt CA-signed certificate. However, the connection between application gateway and the app service is using HTTP protocol, which is port 80. And I'm using the custom domain shailendra.online, which is mapped to the front-end IP of application gateway. So let's open shailendra.online. And this is the sample ASP.NET web application which is created. So let's check the HTTP headers of this web page. Right click, go to the inspect, click on network, reload the page and click on the URL. And you can see response headers and request headers. Request headers are the components which are received from the browser, and response headers are the components of the message which are sent from application gateway. So by looking at the response header, anyone will know that I'm using Microsoft IIS, and in the backend it's only HTTP protocol. As I mentioned, the connection between application gateway and Azure App Service is only HTTP, and it's using the domain shailendra.azurewebsites.net. So to hide this information, we'll rewrite the header rules in application gateway. Let's go to application gateway. Go to rewrites, rewrite set, create a new one. Let's name it as web app rewrites. And let's associate it to the routing rule, which we have. Next, add a rewrite rule. First, let's name it as server because we want to remove the server information. Let's give the rule number as 100. Click on the configuration for this action. It's from the response header, delete. Let's look for server. Okay, create. Let's wait for the application gateway to save these changes. Changes are saved now. Let's go to our website again and refresh. Click on the URL. And now you'll not see the server in the response header. Let's do the same thing with the set cookie, because set cookie is providing a lot of crucial information which should not be available for everyone. Let's go to application gateway again, rewrites, and we'll go to the same rewrite rule and add a new rule. Let's name it as cookie. Give it as 110. Response header, delete, and set cookie. And we'll update the rules now. So the changes are saved in application gateway. Let's go back to the web page, refresh the page, click on the URL, and in the response header, now there is no server and no set cookie. So till now we have learned how to delete the entries from HTTP header. So now let's check whether we need any security headers to be added in the response header. Let's go to securityheader.com and look for our website. Copy this link, type it here and scan. And now it's showing that there are multiple headers like strict transport security, content security policy, X content type options, which are missing from our response headers. But in this video, I'll show few options and how to change them. So the strict transport security, also called as HSTS, is a web security policy mechanism that helps you to protect the websites against man-in-the-middle attack. So when a web server sends this header to the user browser, it informs the browser that it should only connect to the website over HTTPS connection for a certain period of time. As you can see here, strict transport security, maximum age, this is equal to 365 days. And include subdomains means that the policy should apply to all the subdomains of the current domain. So let's create this header into the rewrites. Go to the application gateway. We'll use the same rewrite rule. Next, add a new one. Let's name it as HSTS 120. Configure the action, response header, and we are setting it up. Let's look for strict transport security, and the header value will be, which we have copied, maximum age of 365 days and include the subdomain. Okay, and update. Once the changes are saved in application gateway, we'll check the website. Let's go to our website, refresh the page. And in the response header, you can see the strict transport security header is there. Let's go back to the securityheader.com and scan the website again and see if anything has changed now. And perfect. As you can see, strict transport security header is configured properly. Let's set up X-frame options. So this is an important security header to prevent clickjacking attacks, where an attacker could overlay a malicious page over your website page, and it can trick the users to use their malicious page. And the value of same origin, as you can see, we should apply for same origin. It means that the frames to be displayed should come from the same domain itself. So let's copy this option, go to the rewrites, next, add a new rewrite rule, X-frame 140, and let's configure this response header, set X-frame options, and let's copy same origin. Update the application gateway, and now let's check the changes into the website. Refresh the page, click on the URL, and X-frame option same origin is now part of our response header. Let's scan the page again, and now two security headers are acting perfectly. Let's make a last change to X content type options, and this is an HTTP response header that helps protect against MIME attack, which is sniffing vulnerabilities. So MIME full form is multi-purpose internet mail extension, and it is also called as content type sniffing. Once we'll set up the value as no sniff, then this header informs the web browser to only trust the dedicated content type and don't change the content type into the browser. Let's copy this, go to rewrite rules, next, create a new rewrite rule, X content 150, click to configure response header. If you can't find this option, instead of the common headers, let's click on custom header, copy this and copy the value too. Update. Now let's go back to the website and see if the new header is available or not. And you can see no sniff option, X content type options is available. And we'll scan our website again. Now previously it was showing red, now it's showing yellow. We have to still add these security headers, but for this lab, this is enough. And now our website is partially secure. So to summarize this video, header rewriting is the ability to modify the HTTP headers so that the specific requirement can be met and the security of the web application can be enhanced. So that's all for this video. In this video, I'll explain monitoring and logging options for Application Gateway in Azure. So let's start. I have already created Application Gateway and other resources which are required to deploy a website. So let's go to Application Gateway. There is an Application Gateway named AGW Dev 001. And there is one backend pool with the name Web Server Pool is created, where there is a web server with the name Web Server 01. So if I'll go to the Web Server 01, it's a 2019 Windows server where IIS feature is enabled and a custom HTML page is deployed which will show the name of the server. So let's go to Azure Application Gateway again. The backend setting is using protocol HTTP, which means the connection between Azure Application Gateway and the web server is unsecured. However, the connection between the user and application gateway is using protocol HTTPS, where I have provided the CA signed certificate for custom domain shailendra.online. So if I'll go to the listener, and a web server listener is created with the port 443 and a certificate is provided for shailendra.online. So if we'll go to shailendra.online, this shows the name of the server where the web application is deployed, and it's using protocol HTTPS. As you can see, the connection is secure. Now let's go to the monitoring section in Azure portal, and there are multiple options available: alerts, metrics, diagnostic settings, logs, insights, backend health, and connection troubleshoot. So let's start with the backend health. As you can see, the backend server is healthy and using port 80 and the protocol HTTP. Application Gateway uses the default probes for port 80 or 443, depends on which your web server is listening on, and checks the health of the server. There are another option of using the custom health probes, which I have already discussed in another video, and you can find the link of that video in the description. So if we'll go to the metrics, for the Application Gateway, there are different metrics which are available. And if we'll move the mouse, you can see the description too. So Application Gateway total time, this shows the total time the request has taken when it's processed and the response is sent back to the user. So we'll click here and let's change it to last 12 hours. It'll show the different response time when the website was hit. And because this is a lab and I'm not using this website for anything, so that's the reason there are very less traffic on it. Same way you can check backend connect time, how much time it's taking for the backend to connect, different backend response status, how many bytes are sent and received, you can check, and what are the total number of the requests, you can check from here. There were around 15 requests at 3:47 p.m. There are a lot of metrics which are available. So if you want to drill down or troubleshoot any issue, but if you just want to monitor the Application Gateway, you can go to the insights. And this provides the basic metrics as well as the detailed metrics. Let's change the time range to 12 hours. And it is showing capacity units were used at that time. And each capacity unit is either one compute unit or 2500 persistent connections or 2.25 Mbps throughput. And for the Application Gateway, there are minimum 10 capacity units which are assigned, to which the default billing is set. And if you'll use beyond those 10 capacity units, you will be charged for that. As you can see, the latency from the backend server and the latency from the Application Gateway, all the throughput, unhealthy host count because there is only one server and it's running fine, any failed requests. And if you want to go in more details, there's an option of view detailed metrics. There if we'll change the range to 12 hours. So you can see the performance metrics, capacity units, compute units, connections, throughput. Then you can see the latency. And there is a description also available here. And the traffic, total number of requests, and the different response status for them. And the backend metrics are also available here along with the billing. So in the billing, as I have mentioned, so the minimum billing capacity unit is 10, as you can see here. But if you'll use more than that, you will be charged for that. The benefit of using the metrics option is that you can create the rule from here. So if we'll check the total requests, and you can see the total number of requests are 15. So let's create a new alert rule. Let's see if total number of requests is more than 10, then you should be alerted. Let's change it to 12 hours, apply. And as you can see, over the last 12 hours during 15:42, there were around 15 requests. So let's set the threshold value as 10. Check every 1 minute for 1 minute, loop back period of 1 minute. Set the actions as create an action group, and the region is global, email, and the display name also as email. Notification type should be email, name, alert, email to shailendra.chaudhary@gmail.com. Okay, next action. There are multiple actions which you can create while creating the alert rule. You can use the automation runbook, or you can use the Azure functions, ITSM if you want to create ServiceNow ticket or any different methods. All these can be used here. For now, I'm not using anything. I'll just leave it blank. Review and create and create. And the action group is created. Let's select this action group. Next, details. Let's mark it as severity as very critical. Rule name as alert rule as total requests. Review and create and create. Now this rule will be created, and if there are more than 10 hits, then I should be notified over the email. So let's open shailendra.online multiple times and let's refresh it so that it provides a lot of hits. Let's go to the insight and check the view detailed metrics and total number of requests here. Go to the traffic, select last 5 minutes. It took only few minutes to update the metrics here. And as you can see, there were around 35 requests generated at 23:34. The response status was 300 series. And because we have created an alert rule that if the request count is more than 10, then I should be notified over the email. And I have received the alert for that. So this is the email alert looks like. The metric name is total request. It provides what is the name of the resource group and what is the value. It was more than 10. So the value is 35 over the last 1 minute. So that's how you can view the metric in the insights, as well as you can troubleshoot. And in the metrics, you can dig deep into the different matrices which are available, and you can create the alert rule also from here. Now for the logging option, first we have to enable the diagnostic settings. In this case, I have already created, but what you have to do is add diagnostic settings. There are 3 different diagnostic settings which can be enabled. One is access logs, performance logs, and the firewall logs. The firewall logs will not work in our case because we haven't enabled the web access firewall, but it will mostly be the access logs. So let's select all logs and all the metrics and provide the name, and you can send it to Log Analytics workspace which you have created. Though I have already created this, so if I'll go here, all the logs are going to Log Analytics workspace which is created for this. And it's sending all the metrics as well as all the different logs. So if we'll click on the logs, and there are some alerts and the different requests which are provided here, like the request per hour, you can check directly from here. Either you can check in the form of the chart or in the tabular form, where you can see there are 41 requests which are created. One thing you have to be mindful of is this is UTC time zone, and you can convert it into local time zone and it will provide the time which is in your laptop right now. Because you have created the diagnostic settings, now all the logs of the application gateway are going into Log Analytics workspace. So if you want to check all the access logs, you can use this query. This is a Custo query because the Log Analytics workspace use the Custo query. So let's copy it here. So it's Azure Diagnostics, where the category is Application Gateway Access Logs, and it's sort by time generated. So let's run. Let's run for last hour. And these are all the different logs. You can open anyone and check the properties, different properties here. So if you want to query the request per minute by URI, so you can use this query. So what it's doing is resource provider is Microsoft Network, access logs, and you have to summarize the count by the request URI and provide it here. Instead of the last hour, let's check it for 12 hours and run. So these are the different URIs where the website was reached. However, I have just the shailendra.online page, so the other queries would have been rejected from the backend server. So this is how you can check which request URI are provided by the client or by the user. So if you want to check the different client IP addresses, you can check it. If you use this query, it will provide the summary of request URIs, client IPs, and the request query. Run for last 12 hours. Sorry. You have to select it and run. And then you can see they are the different IP addresses. So like this IP address provided 60 requests. So if you want to block any IP address, you can block it from here. Go to the new alert rule. Table rows count. We are checking the count for 1 minute. Select the dimensions as client IP. Let's select all. If the threshold value is more than 20 in 1 minute, then it should alert. So you can create the actions. You can select the action group which is created for an email. You can go to the details, provide the detail about the alert, and then create it. So in future, if more than 20 requests are generated from any single IP address which we have selected, then we'll be alerted through an email. So this is how you can set up an alert for all the different logs. There are other options also. You can check the different HTTPS status code, which you can check in metrics too, but there is an option to check it from here itself. So there were different requests which got error 404. Some got 400, 200 series, and 300. But if you want to check if someone is trying to reach to your website without HTTPS protocol, then you can check here. So the resource type is Application Gateway, operation name is Application Gateway Access, and SSL should not be enabled. So these are the different, and you can check all the details here. You can filter it down based on client IP or client port or HTTP status. So using the Custo queries, you can customize the different alerts or the monitoring of your application gateway. The last option is connection troubleshoot. And as the name suggests, using this option, you can do the connection troubleshooting. So source is always application gateway here. For the destination, you can use the virtual machines in Azure, or you can specify the URI, fully qualified domain name, or the IP address. And if you'll select the virtual machine, like this is the backend server for us, you can select which destination port it should reach on. So this diagnostic test will check the connectivity as well as the network security group, if the connection is blocked by a network security group or not. To summarize this video, we have discussed about the different metrics which are available for application gateway. Most of these metrics can be viewed from inside through a single pane of glass, and the backend health will be monitored by default. And if you want to use the custom health probes, then not only the port and the protocol can be monitored, in fact the URL or the file can be monitored. And to enable the logging, you have to set up the diagnostic settings in Azure Application Gateway, then all the access logs, performance logs, and if in case you have web access firewall enabled, then the firewall logs will also go to the log analytics workspace. And using the Custo queries, and you can filter out all the requests and then create an alert over there. And finally, we discussed connection troubleshoot, where we can see the connectivity as well as the network security group diagnostics using this. So that's all for this video. In this video, I'll explain the scaling options in Azure Application Gateway. While creation of Application Gateway, you get an option to either select auto scaling or the manual scaling. In auto scaling, you provide the minimum number of instances as well as the maximum number of instances so that Application Gateway doesn't scale beyond that limit. However, in the case of manual instances, you just provide the current number of instances you require at that time. Manual scaling is not recommended for the production use because you have to manually change the number of instances for the application gateway. And in the case of more traffic and utilization, Azure Application Gateway will not scale. And in that case, users will face latency while hitting the website. So let's check the scaling in the lab. Let's go to Azure portal. And I have already created Azure Application Gateway here. Let's go to Azure Application Gateway. There is an application gateway with the name AGW Dev 001. And if we'll go to the configuration, you can clearly see the capacity type is manual. If we'll go to the properties of application gateway, you can see the current instance count. Let's go back to configuration and enable the auto scaling. I'll provide minimum instance count as 1 and the maximum to be 3. Save. Changes are saved now. Let's go back to properties. And now you will not see the instance count here. So that means you don't have insights on how many instances are running for application gateway. Though the billing of application gateway version 2 depends on two factors, static factor where there is a minimum billing and the dynamic factor which involves the throughput, the current connections and data transfer. So if we'll go to the insights in monitoring, you can see the current capacity units. And one instance has minimum of 10 capacity units for which you are billed. If you use more than 10 capacity unit, you will be charged based on that. Let's assume a scenario where there is a traffic surge on your website from morning 11 o'clock to 1 o'clock in the afternoon. So in that case, if the auto scaling is enabled, your application gateway will scale based on the load. But sometimes when there is instant traffic, application gateway takes some time to scale, which can lead to the latency issues on your website. So the solution for this issue is using the scheduled scaling, which I'll show you in this lab using Azure Automation. Let's create an automation account, search for automation, and create a new automation account. I'll select an existing resource group, RJ Dev Application Gateway, automation account name, Dev Auto 001. I'll keep the region as Australia East. Go to next. In this case, I'll use the system assigned managed identity. Next. I'll keep the public access in the network connectivity. Next. Review and create and create. Azure Automation is created now. Let's go to the resource. Now, before we create the runbooks, I'll assign the permission to automation account to make changes in application gateway. Let's look for identity. It's in account setting, identity. Because during the creation, we enabled the system assigned managed identity. Let's go to the permission, Azure role assignments. Right now, this Azure account has no permissions. Let's assign the role. Select as resource group and contributor. Because our application gateway is lying in RG Dev Application Gateway. The role is assigned now. Now let's go back to automation account and click on Runbooks. Let's create a new runbook. Let's name it as Scale Up. The runbook type will be PowerShell and the version will be 5.1. Leave the description as blank and create. Now we have to provide the PowerShell script. I'll just copy paste the script here. So first we are using 3 parameters. One is application gateway name, resource group name, and the number of required instances. And these parameters have to be provided while running this runbook. Either we can execute the runbook manually or link it to a schedule. Then it's using the managed identity where we have provided it permissions on the resource group where application gateway is lying. It's importing the module AZ, and then it's making the auto scale configuration changes where it's providing the minimum capacity. So let's save this. And before we publish, let's test this here. Let's provide the name of application gateway. Let's go to application gateway. AGW Dev 001. Resource group name. And the number of instances. Right now, autoscaling is enabled on Application Gateway, where the minimum number of instances is 1 and the maximum number is 3. Because there will be a traffic surge, we want the minimum number of instances to be 2. So let's set up the value as 2 and start. This will take a couple of minutes to run. I'll be back once the script is completed. Job is completed now. Let's go to Application Gateway, go to the configuration, and now you can see the minimum instance count is 2. However, when we configured the auto scaling, we set up the maximum instance count as 3. But in this case, as you can see in the script, we didn't provide any maximum capacity. So by default, it has taken as 10. So in the script, you can provide -max capacity and add that to in parameters. Number of minimum required instances and maximum required instances. So let's change this. Minimum required instances, copy this and create the new parameter. So this way you will provide both the minimum instance count as well as the maximum instance count. Let's save this and publish. Let's create another runbook for the scale down option. PowerShell 5.1 as the runtime environment. And let's copy the same script. Go to automation account. Go to the runbooks, scale up, view, copy the same thing and paste it here and save and publish. So as we assumed a scenario where the traffic surge happens at 11 AM and dies down at 1 PM. So let's create two schedules. Go to the automation account, go to the schedules, add a schedule, scale up schedule, which will start from tomorrow, 11 AM, Australia time, and another schedule for scaling down. Tomorrow, 1 PM. Create. Now let's go to the runbooks. First, let's go to scale up and link to a schedule. We'll select the scale up schedule, provide the parameters. Let's go to Application Gateway and copy the parameters. Resource group name, number of instances. So we are scaling up. So we want to provide minimum number of instances to be 3 and maximum to be 5. We'll select OK and OK. So when you go to schedules, you can see the next run is tomorrow, 11 AM. Same way, let's repeat for scale down. Link to a schedule. We'll select the scale down schedule. We'll provide the same parameters and save it. And this is how two different runbooks are created. One for scaling up, one for scaling down. I have parameterized all the variables in the PowerShell script. So every time you don't need to create a new script. You have to just provide the variables during linking to schedule or running it manually, and the same script will work for scaling up and scaling down. So that's all for this video. In this video, I'll explain how to set up a start-stop schedule for Application Gateway using the Azure Automation Runbooks. So the cost optimization is the most important pillar for well-architected framework. And the basic principle of cloud is that the resource should be running only when it's in use. So if we'll take an example of Application Gateway, if it's deployed in the production, then we'll not be touching that. However, there could be Application Gateway deployed for dev or test environment where your dev team perform the testing before the release in the production. So in that case, those Application Gateway can be shut down during off business hours or the weekends. So let's go to Azure portal and create an automation for start-stop of Application Gateway. I have already deployed an application gateway with the name agwdev001. And if we'll go to the configuration, auto scaling is enabled here, where the minimum instance count is 2 and the maximum instance count is 10. So that means if the application gateway is running, we will be charged for the minimum 2 instance count. And there are other factors too, which generate the cost, which are throughput, data processing, capacity units. But an ideal application gateway still uses minimum capacity unit for which we are charged. So let's create a new automation account where we'll create the runbook for the start and stop of application gateway. Let's go to automation account, create a new automation account. I'll select an existing resource group, RG Dev Application Gateway, Dev Auto 001, and the region will be Australia East. Next, let's enable the system assign managed identity. And after the creation of automation account, we'll assign the roles and permissions. Let's leave the connectivity as public. Next, and create. Automation account is created now. Go to the resource. Now, before creating the runbook, we'll assign the permissions to the automation account. Let's go to identity. It'll be in the account settings, identity. And as during the creation, we enabled the system assign managed identity. Let's go to Azure role assignments, add a role assignment, select the scope. You can select different scopes like subscription, resource group, key vault, storage, SQL. So let's select the resource group where application gateway is lying and provide the role as contributor. Save. Now this automation account has contributor level of access over the application gateway. Let's go back to automation accounts. Go to the runbooks, create a new runbook. Let's name it as stop app gateway, PowerShell, runtime as 5.1, and create. And now we have to provide the PowerShell script. So this is the PowerShell script for stopping the application gateway. It requires 2 parameters where we have to provide the application gateway name and the resource group name. It uses the managed identity where we have provided the permission over application gateway. It imports the AZ module and then get the details about application gateway and then stops it. So let's test this, save and test. We have to provide the application gateway name. Let's go to application gateway, copy the name. And then provide the resource group name. And start. This will take a while to run, and I'll pause the video and we'll be back once it's done. Runbook has executed successfully. As you can see, the messages here. Now let's go to application gateway and go to the properties where you can see the operational state and it's showing as stopped. So that means our script ran successfully. Now let's go back to the edit option, publish. Now if you'll see, runbook is created and you can run it manually. But you want to add it to a schedule. So let's go to Azure Automation account and create a schedule. Add a new schedule, name stop app gateway. So every Saturday you want to stop it at around 12 AM. Create. Now let's go back to runbooks, stop application gateway, link to a schedule, select it, provide the parameters, copy the name of application gateway, provide the resource group name, and OK. And if we'll go to the schedules, it will show that next run is tomorrow at 12 AM in the morning. Let's create another runbook so that we can start the application gateway on the Sunday morning 8 o'clock. PowerShell 5.1 version, create. Let's copy the same script. So instead of stop, let's make it a start application gateway, and save it. Same way, let's publish it. And while linking to schedule, we can provide the parameters. Let's go back to schedule, create a new schedule, start app gateway. So Monday 0800 8 o'clock. Go to the runbooks. Start runbook. Link to a schedule. Link. Start application gateway. And same way we can provide the parameters. And by this way, both the schedules will be created for stopping and starting during the weekend. And this will save a significant cost on application gateway. So that's all for this video. I hope you liked it. Please like and subscribe. Thank you so much.